Okay. So this is PaperRockOrScissors. We freshly cloned it. And by default, it will be in main. In main, it is like finished in this case. So I want to start explanation from the branch, like the most easy one. And after this, we'll look into complexity. So for this reason, I'm switching branch to the branch called simplest. So I click on simplest in origin, because you don't have local simplest. And I select checkout. After you check out branch from GitHub, it will create local. After this, you will have local here, all right? So I click checkout on simplest. And after this, it is, if you go here, you will see it is also become local. Right? By default, it is checking out entire branch, only default one. But if you want to switch to origin, to another branch from GitHub, you go into origin and do so. Since these branches contain different libraries, we need to synchronize project with elephant button. Somehow Android Studio doesn't figure out that these branches have different libraries, and so it doesn't work you. But it may show errors just because it's out of sync. So again, if we switch branches that use different libraries, we should always click sync button. It's magic elephant, this one. So now it is synchronized, so let's see what it is. Since it's called PaperRockOrScissors, we can anticipate that it's about PaperRockOrScissors, right? It has domain. Domain has a choice, PaperRockOrScissors or unknown. Unknown, it means not decided yet, right? So it will state, since it is storing state somewhere, it will be some state when user didn't decide what is a choice yet. So for this reason, I have unknown. The same, computer at some point will decide what is the choice, but before it is decided, it is unknown. Okay? So in choices, I have 4, because at some point, choice is unknown. I also have game result. Also, I have user wins, computer wins, replay, it means even, like two computer and user pick at the same, like scissors, for example. And unknown, it is at the time when choices are not made yet, so result is unknown. Okay? Since it is stored in state, I really have to have a state when result is unknown, because it's valid state of the program, correct? So in UI, I have 2 screens. One screen, it is to show choices, like pick your choice, PaperRockOrScissors. Click OK after you're done. And this is play screen, and I have result screen. So in this case, I have 2 screens for pick your choice, and here is the result. I have game UI state. And as you see, this is not per screen. It is not per screen. It is per UI. Sometimes it is simple this way. And I'm trying to do it here this way, because first I want to explain simplest. And second, it is in this particular program, it is really simple, because you don't need to pass data between 2 screens if it is already shared in one place. Idea will fail miserably if you have a lot of screens, because you will have to share all the data in one place, and it will create a mess. Typically, for larger applications, we need to have a view model per screen. In this case, it is not per screen, it is per entire app. So I have game view model and game UI state. So game UI state, since it's not per screen right now, I have an extra flag, but later we will get rid of it. Okay? And this is actually what is shown, which screen is shown. Either play screen or result screen. So I also have a variable screen, which is play and result. Okay. Speaking about this program is not using Android navigation system. It is using brute force navigation, and it is not stupid hack. I saw examples written this way from Android, from developerandroid.com. So it is acceptable, but for only small applications. Idea fails miserably if we have multiple screens. This way it will create a huge mess. So in this application, we will have a both so we can compare. Now, I create this enumeration class that tells me which screen to show, play screen or result. Okay? So in my state, game UI state, first variable, it is, by default, it is show play screen. User choice unknown, because when we start, user didn't make a choice. Computer choice unknown. When we start, computer didn't make a choice yet. And result is also unknown. Okay. So these are defaults for the constructor. So when we call constructor of user interface, a constructor of game UI state, it will create object for us with these defaults. I have game view model that is storing game UI state in mutable state flow. Why? We don't have to. It's again for practice how to deal with mutable state flow. We could use just mutable state. It will be simpler, but for practice, we need to learn how to write large applications, right? Because eventually you will need to do capstone. If you choose doing capstone, it is not simple. You need to know better approach acceptable for large applications. Yes. Plus, if you look up example for navigation from Google, you will see that in that Google course, they is already using mutable state flow. So we need to learn it. Okay. So what I have here, I have mutable state flow, mutable state, which is private, and regular state flow, which is public. It's the same idea. I'm hiding ability to change it, right? So this state is changeable inside of your model, but it is just exposed, read-only, to outside of your model. Okay. As you see, this is referring to the same variable. Mutable state flow with parentheses, it is just constructor call. And this constructor call receives object to initialize the container. And this object is created by constructor call of the state, right? And what is this? Play screen, no, right? Next, what is this thing? This part is providing business logic. And as you see, this is not done flexible way, and this is why this branch is called simplest. Why it is not done flexible way? Because I hard-coded this part. I explicitly call constructor here of something that provides business logic. It is not given as a parameter. It means I cannot change our implementation of it, right? And again, this is for simplicity of explanation at this moment. Next branch will have this outside. Okay. So let's look at what is game service. Game service is defined here in data, local, because this is provided like a local logic. Why? We technically could, in fancier way, we can play with the computer on the internet. This way it would be not local. data. Right? If you play with program running on a server, right, this wouldn't be local. And since this is local to your device, this is why I have folder local. All right? So what I have here, in order to implement business logic, I have to have something that gives me random choice, which is choice, paper, rock, or scissors. Unknown it's outside. It's not random. It's random choice. It's paper, rock, or scissors. In this case. And game result. When you provide choice of a user, computer choice, it's supposed to return game result. Who is the winner? All right. So if I implement this interface, I have a business logic okay. So let's see at the implementation. Here is the implementation. The same. I created parameter, which is random number generator. So this class will be testable in reproducible way. I've already covered this before. But we don't have to provide this parameter when we call constructor because it has default value. I also have internal array of choices. So not array, internal list of choices. How did I make it? Choice, it's enumeration type. If I call values, it will create array of possibilities out of this enumeration type. Paper, rock, scissors, unknown. But I want to drop out unknown in this case because it's not really a choice. It's one of options to store state, right? So I slice it and I pick indices between 0 and 2. This part, it is clue inserted by Android Studio. I type it 0.2. Okay. So I'm creating list with paper, rock, scissors. Okay. So this is list of paper, rock, scissors. So when I call get random, it will pick random element out of this list, paper, rock, or scissors. So this is how I get random choice. Okay. Next, game result. User choice, computer choice, and it is returning game result. Instead of using bunch of ifs, I can use when inside of a when, because when is returning result, okay, in Kotlin, right? So when user choice is equal to paper, I have another when inside. If user choice is paper and computer choice is paper, game result replay. If user choice is paper and computer choice is rock, game result user wins. Okay. So it is when inside of a when returning result. If user choice is paper and computer choice is scissors, computer game result is win. And I have none of the above, which is unknown, right? Unknown. Game result unknown. So I repeat this logic 2 more times to decide who is the winner. Right? So the same. If user choice is rock and computer choice is paper, result computer wins. So this is how I coded decision making. Why? Because when is returning result? So you see result equal to, so I don't have return statement because it's just one statement. This is just one statement, assign it to the function. Okay? I was thinking how to do it shorter. This is probably shortest. Okay. So this is my business logic, and I created object by calling this constructor in my view model. So my view model contains this object. So I can call get random choice from it, and I can call get winner. Yes?
can you go back to game service implementation? When you create the list choices, private file choices.
This?
No, line 11.
Uh-huh.
Are you just creating a list of 3 elements?
First 3, because I need to drop unknown. This is only reason. Because when I call random on choices, I don't need to include unknown because I will call get random choice when somebody is making decision. Is a computer or computer making decision. So when computer makes decision, it shouldn't include unknown. So this is just for sake of dropping unknown. Slice between index 0 and 2, 3 not included, 3 is unknown. Okay? So can we go back? Yeah, okay. So we're here. When user clicks play button, I need to change state. But I change state only when user made selection. When UI state value user choice is not equal to unknown. Okay? Because if user didn't make a choice, I cannot calculate result. So on play doesn't do anything if user choice is unknown, right? Logically, it shouldn't. It means your user didn't select any radio button at this moment, but clicked play. Okay. So play will not do anything until user choice is known. Okay. When user choice is changing, on clicking the radio button, similarly to calculate tip calculator, I have a function on user choice change that is doing update of the state. It is not doing recalculation because recalculation is done on play. So the same, I'm changing flow, state flow, right? So this is new choice. I'm updating state by calling update. This is lambda function that is changing state. This is current state. And I'm creating copy of the current state by changing user choice to this one. Okay. Remember how we did it for service quality change? The same idea, right? In that case, it was service quality, new service quality, service quality. But in addition, we had recalculation of the result because that program was recalculating results when we changed radio button choice. Right? In this case, there is no recalculation because result is calculated when we click on play. There is a play button in this program. So result will be only calculated after we click on play. So result is here. Okay. When we click on play, current state, then I'm doing copy. Of a current state. Why do I copy computer choice? I shouldn't, I don't have to, right? It will be preserved, I don't have to copy. Let me think 1 second. Computer choice, computer choice. We don't have to copy because it's already inside, right? So this line is not necessary. Get rid of it. Okay. So at the time of the copy, I need to change game result and switch to the screen, new screen, right? All right? So game result is coming from game service get game result. I'm providing user choice, computer choice. No. It was all right. Why? Okay. Going back. Roll back. This is this variable. Okay. Get random choice. See? This is why we're changing. Otherwise, it will stay unknown. So computer is making choice when we call on play. So this is, you see, computer choice, game choice, get random choice. Before this, it could be unknown or previous state, whatever is there. Unknown probably, yes, unknown. So this is why we need to override unknown. So this is not a bug, it's feature, it needs to be there. All right? Then we calculate game result by calling service, get game result, for given user choice, for given computer choice. Right? And we change screen to result. Right? But this is not changing screen, it is just changing state of the GUI. Correct? Are you with me? So we copied object that describe GUI, state of the GUI. Okay. What happens on replay? On replay, I'm creating new state because it's starting from scratch to default. So this is default constructor, and I assign it to the value. There's no need to call update because it is just brand new object. There's no point of changing every value. We can just create brand new object and assign it to the value. Okay. So this would happen on replay, and this will have a different screen. It is play screen. Okay? So let's run it, and after this we'll go to GUI and see how it works. Okay. So this button is disabled till I make selection. When I make selection, like rock, for example, this becomes enabled. I click play, and computer made decision, and now it's result. So I need to make it bigger probably. So let's do it. View mode, window, so I can stretch it. Okay. When I click replay button, again, this is disabled till I make selection. So it has extra logic to do disable, right? I select it, now it's enabled, and this is result. So this is only thing. So I need to make some decision, logic that is changing screens. Where did I put it? Remember that there is a app screen function. So it is inside of this. So it started as before. This is view model by calling view model function. How this view model function behaves? It will find view model if it exists and will attach it, or create new one if it doesn't exist. If you just starting your program, it doesn't exist, right? If you rotate the screen, it's its previous state, so it will be saved. This way, it will find it and reattach it. Also, if you are returning, no, you are not returning. This returning will be logic is here, right? So this is reattaching view model when necessary, right? Or creating new one. Remember that view model contains flow, but in order to trigger screen, we have to collect it to state. Now it is state. I'm using by shortcut, and this is delegation. So this variable is delegating getter to the container. So each time when we use it, it calls get value from the container. All right? So what is here? If UI state screen, it has a screen variable in it, remember? Equal to play, we show play screen function. Okay? Play screen, composable function. If if UI state screen is result, I'm showing a result screen. Okay. So it is just when, right, with two outcomes. Okay. So play screen expects user choice, a link what to do when user choice is changing, because view model content is changing when user clicks on radio buttons. Remember? Because it is storing state of user choice. So it needs access to content of view model, and this is changing content of when user is clicking radio button. Okay. And remember that view model is resetting state to original state on play. So this is lambda function created from function inside of view model. Double column, it is converting regular function to lambda function. And this will be called when we click on play button. No, on play it's not resetting. It's doing calculation and goes to next screen, right? It's not reset. Reset is on replay. Correct? So on result screen, it shows user choice, computer choice, game result, and it needs to execute some action when we click on replay, right? When we click on replay, content of this container is changing, right? So this function is re-executed, and we will end up in play screen. Okay. Questions? Oh, I didn't explain GUI yet. It is business logic and view model now. Okay. So you see it is quite simple, right? And for such programs, it's probably the simplest choice when you have two screens. It works fine, and it is not like I'm doing something really naughty. Google examples do it. But it doesn't work if we have multiple screens. It becomes really messy this way. Right? So let's look inside of these play screen functions. Okay? Play screen and result screen functions. Okay? It is play screen and result screen. And I re-emphasize that in this case, view model is not per screen, it is per entire app as you saw. Right? So play screen, what is there? Receiving user choice, a lambda function that will be executed when user clicks on a button, radio button, and on play, lambda function that will be executed when user clicks on play button. Okay. Next, everything on the screen is inside of column. I probably want to open this so it's easier to go to replay. Okay, so I have column, I have text, PaperRockOrScissors, it is this one, in pink. After this, I have a text box in green, make your choice. Okay. After this, I have user choice input, it is wrapped 3 radio buttons, it is this one. I'm passing lambda function on user choice change, because this function needs to call on user choice change when we click on radio button. So it needs to have access to this lambda function, right? It needs to react on radio button click. But it also needs to display which is selected. So this is what is the value which is selected. Because when you select it, you see it's showing what is selected. So this is what is currently selected. And this is executed, lambda function executed when we click on radio button. Logic is exactly the same as inside of calculator. I copy pasted it. So user choice input. You see I have a row with radio button and text. It is selected when user choice is equal to paper. It is the first one. We had this logic when service quality is equal to amazing, right? So the same idea in the same even number of radio buttons, right? I compare choice instead of service quality. When first radio button is matching, it becomes selected, right? And what is called when we click on change and choice is passed as a parameter. See, on change and choice is passed as a parameter. So it will execute lambda function each time when we click on it. And the same as here. On change, and in this case, rock is passed as a parameter because we click it on radio button that is matching rock. Okay? So in the same as this one. Going back, so this is input, user input. This is coming from user choice, and user choice is coming from view model. Right? And finally, we have a button below user input. On click, it's calling on play, right? And on play, it is this one, lambda function, and it is assigned from view model on play. So it will execute function inside the view model on play. Okay? Right. But I also have enabled. This will be enabled when user choice is not equal to choice unknown. So when user didn't select anything, it's unknown, I cannot play. So this is why when I return to this place, you see, by default it becomes unknown, it is enabled false, right? Because it's not equal to unknown. All right? In text, it is play, and icons, check mark. This check mark. These icons are not included by default. We have to include library, surprisingly. Okay. So I will show which library I included. It's another thing. So I will talk about libraries later, but let's look inside of results screen. On results screen, I have this label in pink. So I have a column, PaperRockOrScissors in pink, game result in green. After this, I have 3 rows. You see not 3 rows, 2 rows, right? First row, it is word computer and computer choice, whatever is there, right? Converted to string. Why I need to convert to string? Because this is computer choice, it is type choice. But I want to display it as a string. Not just as a string, it's a string in current language. So it has to go into string XML. Okay. So this needs to be converted from string to string XML. So choice to string is a function separate. Choice to string, it's picking choice and returning string. So how it works? If choice is paper, getting string resource, ID paper. Okay. When choice is rock, getting string resource, ID is rock. So it is picking strings from string resource. In string resource, it is according to language of a user preference. This program has only English string resource, but we can add other languages. If you can translate, you can add them. And this would be switchable between, according to device preferences. So this is existing for sake of conversion choice into string. I also need to convert who is the winner into some string. Right? Because enumeration type game result is not how it is displayed on the screen. Right? So I want to, if user wins, I want to show you are the winner. If computer wins, I want to show computer wins. Right? So this is how IntelliJ, Android Studio is showing string resource. It is wrapping it so we can see content. Okay. So this is conversion. So the same is user choice, computer choice. I'm calling this conversion. And finally, it is result. Right? Result to string is converting result into proper string. Right? And this is in orange. Okay. And this is one line. It's not wrong. Okay. And button, replay. Okay. This text on the button is picked from the resource, and content description is null because text on the button is enough. We don't need to. Content description is useful if you have just icon. So screen readers can say what it is. Okay, so this is how GUI works here. Okay. Next, let's look up in libraries and see what I included in libraries. I open Gradle. In the global file, it is default. I didn't change anything in global. In local, I had to add view model compose. No, I didn't add icons. No, these icons are default. I had another example where I had to include icons. So I only added view model, nothing else. Okay. Questions? So please play with this code at home. Let's look inside. If you have questions, ask. So this code is just kind of starting, okay? And next, I want to fix one issue at a time, okay? Plus, it's also introduction back to our dependency injection that we talked, but we didn't actually walk it through how it works. So in my game view model, you see that this is hard-coded constructor call. And if I want to replace it, I will have to just replace view model, right? So this is replace code inside of view model. So this is hard-coded relation. It's not injection because it is call of the constructor inside of the class. Right? So if we pass as a parameter, it would be injection, but who will assign it? Remember that magic function, view model, right? That will create object if it doesn't exist or find what exists. So we need extra mechanics for the function to tell the function where to get this piece. Right? There is a way to do it. How to provide this information to the system so proper constructor will be called. So there are two ways. One is called manual dependency injection. You do more stuff on your own in your code. And one is called Hilt dependency injection because it is using Hilt framework to inject dependencies. Comparison. Manual dependency injection, you have to write more code. It is not recommended because it becomes massive for large projects. Google covers it for some simple examples. And I will have one example with manual dependency injection, so you just saw what it is, okay? But right now I want to explain Hilt because this is recommended by Google for any kind of projects. It's beyond elementary. Okay. So next branch is dealing with injection of business logic here. All right. But I also created two additional classes, like domain layer, two use cases. So essentially it is injected in use cases, and use cases are injected here in view model. To show how to do injection like in two stages, okay?